Hello everyone and welcome to Growing 1.3. Our learning targets today remain fairly similar to the ones we had yesterday. We want to be able to compare different exponential growth patterns and be able to write equations for those exponential growth patterns. Our homework for 1.3 will be number 13, where things quadruple, 15 through 21, and 45 through 47. So as we look to page 11 in your book, we're finding that maybe the Kings decided needs to make a new offer, otherwise might go broke. As you found out yesterday, those numbers added up fairly quickly. So the patterns of change in the number of ballots in problem 1.1 and in the number of rubas in problem 1.2 show exponential growth, meaning they multiply by a number every time. If we take a look at our vocabulary definition here, exponential growth is a pattern of increase in which each value is found by multiplying the previous value by a constant factor greater than 1. For example, the doubling pattern 1, 2, 4, 8, 16, 32, so on and so forth, shows exponential growth in which each value is 2 times the previous value. Well, in each case, we can find the value for any cut or square by multiplying the previous value by a fixed number. This fixed number is called the growth factor, or the number that you multiply by. In this example, it was the 2. As we look at the vocabulary here, the constant factor that each value in an exponential growth pattern is multiplied by to get the next value. The growth factor is a base in an exponential growth equation. We found out the definition of base yesterday. Well, the growth factor is the same as base and is a number greater than 1. You can pause the video if you want and read further down here. These relationships between our exponential growth and our growth factor are called exponential functions. Exponential functions are relationships between two variables that are exponential. For example, the function represented by y equals 4 to the n minus 1 power for placing 1 ruba on square 1, 4 rubas on square 2, 16 rubas on square 3, and so on is an exponential function. So the number of the cut or square is the independent variable. Remember independent variables and dependent variables that we went through with thinking with mathematical models? Well, let's go back to that. So we're going to have a y, or whatever letter, y equals, we're going to have our growth factor times a independent variable of x, or n, as we like to use for exponential numbers. So the number of pieces of paper rubas on the square is the dependent variable. It depends on what the independent variable is set as. So let's think back to 1.1 and 1.2. What were the growth factors for each of those? Well, it turned out that they were the same. They each had the same growth factor of 2. And hopefully that's what you found out in your exercises of 1.1 and 1.2. So if we turn to page 12 in your book, it says, the king told the queen about the reward he promised the peasant. The queen said, "Oh, you may have promised her more money than the entire royal treasury. You must convince her to accept a different reward." So plan 2, the king's new plan. After much thought, the king came up with plan 2. He would make a new board, aha, with only 16 squares, that sneaky little king. Then he would place 1 ruba on the first square and 3 rubas on the second. He drew a graph to show the number of rubas on the first 5 squares. He would continue this pattern until all 16 squares were filled. Well, then the queen, not so trusting of her husband. So the queen's plan says the queen was unconvinced about the king's new plan, so she devised plan 3. Using a board with only 12 squares, haha, she would place 1 ruba on the first square. She would use the equation r equals 4 to the n minus 1, or if you want to use letters that you might be more familiar with, y equals 4 to the x minus 1, to figure out how many rubas to put on each square. In the equation, r, or y, is the number of rubas on square n, or x. Okay? So if you look at your the problem 1.3, and the lab sheet from 1.3, which is going to have lots of tables for you to record all of this information on, and a graph for you as well. I want you to do problem 1.3, parts A, B, C, and D with your team, and report to me what you find out for part D. Then you'll be on to homework for 1.3. As I said, number 13, quadruples, 15 through 21, and 45 through 47. Look forward to hearing your questions and challenges in the classroom.